Okay, so, as philosophers, when we think about Isaac Newton, right, the first thing that pops into our heads, well, is probably gravity or calculus, or maybe that really thick book, the Principia.
Yeah.
But, and this is kind of mind-blowing when you really dig into it, Newton wasn't just a science guy. Like, he was super into alchemy, theology, even biblical prophecy, all this stuff that, at first glance, seems totally unrelated to physics and math.
Yeah, it's funny, right? Because in philosophy, we tend to view Newton as this pivotal figure, not just in the history of science, but also in how we think about knowledge itself, epistemology, or even metaphysics with all those questions about cause and effect, especially with his ideas about gravity.
For sure. And today, we're kind of taking a different approach. We're not going to get bogged down in all the physics equations and stuff. I mean, you, as a philosopher, you've got that background already.
Right.
What we're going to do is use this awesome entry on Newton from the Stanford Encyclopedia of Philosophy. It's really detailed, and it digs into all the philosophical stuff that's often overlooked when people talk about Newton. It's a deep dive, tailored specifically for philosophers.
And that's what's so cool about this. We want to show you, the listener, the connections between Newton's work and the big philosophical questions that people are still grappling with today. We're talking about how we know things, the nature of reality, stuff like that.
Exactly. So how are we going to tackle this philosophical journey, right? What are we going to look at today?
Okay, so first we're going to rewind a bit back to Newton's early years and the intellectual scene of his time. We'll look at how all that might have shaped his, kind of unique way of thinking.
Yeah, the context is always important.
Then we'll dive into his major discoveries, gravity, optics, all the breakthroughs, and we'll look at how people reacted to them at the time, especially all the philosophical pushback he got, like the whole action at a distance thing with gravity. That caused a lot of controversy.
People really had a hard time with that one.
Well, oh, yeah. From there, we'll trace how Newtonianism as a philosophical and scientific system kind of took shape and evolved. It's not as straightforward as you might think. And finally, we'll tackle the big question. How do we, as philosophers, make sense of this incredibly complex and sometimes contradictory figure? How do we reconcile all the different facets of Newton's work?
All right. A lot to unpack. Should we start back in the 17th century with young Newton?
Let's do it. So picture this. England in 1642, it's the middle of the English Civil War, total chaos. And on Christmas Day, according to the old calendar, Isaac Newton is born. It's also the year Galileo dies, which some people see as kind of symbolic.
Wow, that's kind of a dramatic start.
Right. And on top of that, you've got this intense religious backdrop. Newton's family were Puritans, and the Church of England had a lot of sway over the universities at the time. So you can imagine how all this religious and political turmoil might have influenced his worldview, even if it's hard to pinpoint exactly how.
Right, it's hard to separate someone from their context. And early on, he received a pretty standard classical education, right? Like lots of Aristotle.
Exactly. His early education was all about the traditional liberal arts. Logic, rhetoric, ethics, and of course, Aristotelian physics, which was kind of the default back then.
Right.
But by the mid-1660s, he's like, okay, I've got to go beyond this. He starts devouring Descartes, the Meditations, discourse on method, even his stuff on optics, which he found super fascinating.
That's such a huge shift from Aristotle to Descartes. Talk about a philosophical leap.
And alongside that, he's diving deep into the mathematics of folks like Oughtred, Viet, Wallace, and of course, more Descartes. He's clearly hungry for knowledge, pushing the boundaries of what he was taught.
So this is all before he makes those big discoveries, right?
Yeah, and then comes the Annus Mirabilis, the miracle year, between 1665 and 1667.
Yes, the plague years.
Right. Cambridge closes down because of the bubonic plague, and Newton has to go back home to Woolsthorpe. And what does he do during quarantine? Well, he basically lays the foundation for modern science. He starts working on optics, figuring out the composition of white light. He develops the mathematical theory of uniform circular motion, which is like a precursor to understanding planetary orbits. And, get this, he makes significant progress on calculus years before Leibniz does, although that priority dispute became a bit of a philosophical mess later on.
Yeah, the calculus wars. Whole other deep dive right there.
Absolutely. But what's fascinating from a philosophical point of view is that he achieved all this during a period of intense isolation, working completely on his own. It makes you wonder about the conditions that foster creative genius, right? Like maybe sometimes being away from the academic echo chamber can be a good thing.
Interesting thought. So plague ends, Newton heads back to Cambridge, and in 1669, he becomes the Lucasian Professor of Mathematics. And the basis for this prestigious position is his work on calculus, what he called day analysis.
Yeah.
But then He kind of puts it aside.
It's strange, right? I mean, calculus is like a revolution in mathematics. But he doesn't publish it right away. Maybe he felt like people weren't ready for it. Or maybe he just had other things on his mind. He starts focusing on algebra, even doing a deep critique of classical geometry. It's like he's questioning their foundations of mathematics itself.
Almost like a philosopher of mathematics.
Totally.
And then, in 1672, he finally publishes his work on optics. And that's when things get a little bit spicy, right?
Oh, yeah. Things heat up. He publishes in the Philosophical Transactions of the Royal Society, and it immediately sparks controversy. Robert Hooke, another big name in science at the time, starts criticizing his ideas. So does Christian Huygens, who's famous for his work on light and pendulums. It was a whole thing.
Yeah, science can get pretty cutthroat sometimes. And philosophically speaking, this whole debate is really interesting because it shows just how hard it can be to introduce radically new ideas. Even when you've got experimental evidence to back it up, people who are used to thinking a certain way, it's hard to change their minds.
Totally. It raises questions about how knowledge is accepted, how consensus is formed, the role of authority in science, all sorts of philosophical issues.
So we've got Newton, who's already shown he's brilliant but also kind of sensitive to criticism. He's having these public debates about optics, but behind the scenes, he's working on something even bigger, even more revolutionary.
Right.
Universal gravity.
And this is where Edmund Halley comes in. He asks Newton this seemingly simple question about the path of a planet if gravity follows an inverse square law, meaning the force of gravity gets weaker with the square of the distance.
Simple question. Huge implications.
Absolutely. And Newton's response blows Halley's mind. He's like, oh, yeah, I've already figured that out. It's an ellipse. And Halley basically says, dude, you have to publish this. So Newton gets to work. And in 1687, he publishes the Principia, which, let's be real, completely changed how we understand the universe.
So Source actually calls it the most important work in the transformation of natural philosophy into modern physics.
It's a masterpiece. He uses rigorous mathematics to show how gravity governs everything, from the falling apple to the motion of planets. It's like he's unified heaven and earth under one set of laws. Philosophically, it's a huge win for the idea that mathematics can describe the fundamental nature of reality.
But, and there's always a but in philosophy, right? Not everyone was on board with his theory, especially on the European continent. And a big part of that resistance, again, was the idea of action at a distance.
Oh, yeah, that was a major sticking point. Thinkers like Huygens and Leibniz, they just couldn't wrap their heads around how gravity could act across empty space. It seemed like spooky action at a distance, almost like magic.
Like something out of the occult.
Exactly. They were all about the mechanical philosophy, which said that forces had to be transmitted through direct contact, like gears in a machine. So the idea of gravity acting instantaneously across vast distances without any physical connection, it just didn't fit into their worldview.
This is a classic example of how philosophical assumptions can shape how we interpret scientific theories, right?
Totally. It raises all these questions about what counts as a legitimate scientific explanation. Does it have to be purely mechanistic? Or can mathematical description be enough, even if we don't fully grasp the underlying mechanism? These are questions that philosophers of science still grapple with today.
So how did Newton's theory eventually win people over, despite these philosophical objections?
Well, the proof was in the pudding, as they say. Over time, Newtonian gravity proved incredibly successful at explaining and predicting all sorts of celestial phenomena. It explained the tides, the precession of the equinoxes, the slight variations in planetary orbits. And as more and more observations confirmed his theory, the resistance gradually faded.
So, by the mid-18th century, Newtonianism had become the dominant scientific framework, even in continental Europe. But it's interesting because what we call Newtonian mechanics today is actually the result of a lot of development and interpretation that happened after Newton, largely by those continental thinkers.
Right. It's important to remember that Newtonianism wasn't just a static set of ideas handed down from Newton himself. It was constantly evolving and being shaped by other brilliant minds. People like Voltaire popularized Newton's ideas for a wider audience. And then you have folks like Pemberton, Maclaurin, Clairaut, Euler, D'Alembert, Lagrange, Laplace. They took his basic framework and developed it into a much more sophisticated and powerful system.
It's almost like a philosophical game of telephone, right?
Yeah.
Where the message changes a little bit, with each retelling.
Exactly. And what makes it even more complicated is that we have to distinguish between the public Newton, the author of the Principia and Optics, and the private Newton, because it turns out Newton had all these unpublished writings on math, alchemy, and even some pretty radical theological views.
Oh, yeah, he wasn't exactly orthodox, was he?
Not really. He was anti-Trinitarian, for one thing, which was a pretty big deal back then. And he spent years studying biblical prophecy and alchemy. So you have this whole hidden side of his intellectual life that didn't really become public until much later.
That makes it really tricky to try and pin down a consistent philosophical worldview, right?
It does. I mean, which Newton are we talking about? The public, scientific Newton, or the private, more esoteric Newton? And can we even reconcile these two seemingly different sides of his personality? These are questions that historians and philosophers of science are still debating.
It's really a philosophical puzzle.
Yeah.
And even within his published scientific works, there are these different Newtonian traditions, right?
Yeah.
Like the one stemming from optics versus the one from Principia.
Right, exactly. With optics, you see this emphasis on meticulous experimentation, careful observation, and the importance of grounding your theories in empirical data. This book inspired generations of scientists to study light, color, and the nature of vision in a very hands-on way.
Yeah, good science, right?
Absolutely. But then you have the Principia, which is all about mathematical rigor and deriving universal laws from first principles. It's much more abstract and theoretical.
So, two different approaches, but both grounded in a deep respect for empirical evidence.
Yeah.
Right.
Exactly. And that's what sets Newton apart from someone like Leibniz, who was more willing to speculate and propose grand theories without always having the empirical support. I mean, just look at their famous dispute over who invented calculus.
Oh, man, that was nasty.
It was. And beyond just the priority dispute, it highlights a fundamental difference in their philosophical approaches to knowledge. Newton was always super cautious. He'd say, look, we can only go as far as the evidence allows us. We shouldn't speculate beyond what we can actually observe and test.
And this cautious approach is evident in how he dealt with some of the big, unanswered questions of his time, like the cause of gravity, for example. He never really offered a concrete explanation for why objects attract each other.
Right. He could describe how gravity worked mathematically, but he didn't try to explain the underlying mechanism. And the same goes for the nature of light. He did lots of experiments suggesting that light was made of particles, but he also acknowledged the wave-like properties of light. He didn't try to force a definitive answer where the evidence was inconclusive.
That's a real commitment to intellectual honesty, right? Acknowledging the limits of what you know.
Absolutely. And you see this same kind of cautious approach in his views on mathematics. I mean, he developed calculus, which is this incredibly powerful tool, but he always insisted that its true rigor came from its geometric foundations, not just from manipulating symbols.
Interesting. He seems to have had a more grounded, less abstract view of mathematics.
Yeah, and it's even more fascinating when you consider his work on alchemy, which was kind of a taboo subject for a respected scientist. He spent years doing alchemical experiments, but it's kind of a separate thing from his public scientific work.
So it's tough to integrate his alchemy into a coherent philosophical framework.
It is. Some scholars argue that there are connections between his alchemical ideas and his more mainstream scientific work, but it's still debated.
It's like we keep coming back to this idea of Newton as a puzzle. But one thing's for sure, without the Principia, our whole understanding of him would be completely different.
Totally. It's the foundation of his philosophical legacy. But even the Principia wasn't immediately understood or accepted by everyone. I mean, it's a dense book full of complex mathematics. And even as it gained popularity, a lot of people who claim to be Newtonians probably only grasped a fraction of its full depth.
So even with something as groundbreaking as the Principia, there's this process of interpretation and reinterpretation.
Absolutely. And it's important to remember that science isn't static. The Principia was this amazing achievement, but it also left some unanswered questions. It took decades for other scientists to really work out all the details and extend its applications.
Like, for example, Clairaut and Euler figuring out the shape of the Earth and explaining those subtle variations in the moon's orbit. That was all based on the Principia, but it took their work to really flesh it out.
Right. And one of the most significant contributions came from Euler, who basically took Newton's three laws of motion and transformed them into what we now call Newtonian mechanics, like the famous equation F equals ma. That's Euler's formulation, not Newton's.
So even the most fundamental equations of physics are the result of this ongoing process of refinement and interpretation.
Exactly. And the success of Newtonian mechanics, especially in astronomy, led to a whole new set of philosophical questions. People were like, how is it possible that we can predict the motions of celestial bodies with such incredible accuracy? What does this tell us about the nature of the universe and our place in it?
Yeah, philosophers like Locke and Berkeley were already wrestling with those questions in Newton's own time. And later, Kant would build his whole philosophical system around trying to make sense of Newtonian physics.
It really was a turning point in the philosophy of science. And then, of course, in the 20th century, you have Einstein and the theory of relativity, which kind of throws a wrench into the whole Newtonian picture.
Kind of, but it's more nuanced than that.
It is. Relativity shows that Newtonian physics isn't wrong, it's just a special case, valid for most everyday situations. It's like a really good approximation that breaks down at extreme speeds or in super strong gravitational fields.
So it's still incredibly useful for most purposes. It just has its limits.
Exactly. And that's kind of a philosophical lesson in itself, right? That even our most successful scientific theories might only be partial truths, valid within certain boundaries.
So to wrap things up, what are some key takeaways for our philosopher listeners?
Well, first, I think it's important to appreciate the sheer complexity of Newton. He wasn't just a scientific genius, he was also a deeply religious and somewhat secretive figure who was fascinated by all sorts of things, from alchemy to biblical prophecy.
Right, not just the guy on the apple juice bottle.
Definitely not. And second, we need to be careful about interpreting his work. It's easy to cherry pick quotes and try to force them into our own philosophical frameworks. But to really understand Newton, we have to consider the historical context, the different Newtonian traditions, and the ongoing evolution of scientific and philosophical thought.
And finally, I think it's worth asking ourselves, how should we, as philosophers, approach figures like Newton? How do we reconcile their brilliance with their flaws, their scientific achievements, with their more speculative pursuits? It's a question that goes beyond Newton himself. It's about how we understand the history of ideas and the complex relationship between science, philosophy, and the human search for knowledge.
Couldn't have said it better myself.
And that's a great place to leave it for our listeners to ponder. Thanks for joining us on this deep dive into the philosophical world of Isaac Newton.